Welcome to the deep dive. Today we're really digging into Amazon DynamoDB. Not just the basics, but the core stuff, partitions, global tables, and indexes. These are the pieces that, well, make it tick for those huge scalable apps. We're using the great material you sent over, ready to unpack this.
Absolutely. You really can't build effectively with DynamoDB on a global scale without getting these three concepts down. They're fundamental.
Okay, let's start with partitions. I think of them as the backbone, really. What are they fundamentally? The sources say physical storage units.
That's right. Think of them as separate containers, yeah. DynamoDB splits your table's data across these partitions, and it does that based on the partition key you choose when you set up the table.
Ah, the partition key. So that's how it decides where a piece of data actually lives.
Exactly. It hashes that key value and uses the result to assign the data to a specific partition. This lets it spread the load across lots of servers. It's not all sitting in one place.
And that's why it scales so well horizontally. Right?
Yeah.
More data or more traffic just means potentially more partitions.
Precisely. And DynamoDB handles adding those partitions automatically behind the scenes as your needs grow. That's the beauty of it.
Okay, practicality. The sources mention specific limits per partition.
Yeah, that's important. Each partition can handle, let's see, up to 3,000 read capacity units, RCUs, and 1,000 write capacity units, or WCUs.
Per second.
Per second, yeah. These units basically measure your throughput.
So choosing that partition key sounds critical then, if you choose poorly.
You get bottlenecks, big time.
Yeah.
You need a key with what we call high cardinality. Lots and lots of unique value.
Like a userid, maybe? Something that's likely unique for every item.
Perfect example. Something like userid is usually great. If you use something like, say, status, where there are only a few possible values.
All the pending orders would hit the same partition.
Exactly. That's a hot partition. It gets overloaded while others sit idle. Performance tanks, you absolutely have to design your keys to distribute the workload evenly. It's probably the most critical design choice.
Got it. So partitions give us that core scalability within a region. But what about global applications? Users everywhere. How do we get low latency for everyone?
Ah, good transition. That's where global tables come in.
Okay, global tables. What are they, essentially?
They're basically fully managed multi-region, multi-active tables. You define which AWS regions you want your table to exist in, and DynamoDB handles replicating your data across all of them automatically.
So if I write data in, say, the US East region.
It gets replicated to your other chosen regions, maybe in Europe or Asia. Usually that happens in under a second.
Wow, under a second. That's fast for cross-continent replication. What's the main benefit there? Low latency access.
Low latency is a big one, yeah. Users connect to the closest region for quicker reads and writes. Plus, it provides disaster recovery. If one region goes down, your app can keep running using another region.
Makes sense. The sources mention something called eventual consistency, though. What's that about?
Right. So because the replication takes some time, even if it's less than a second, there's a brief window where a write made in one region might not be visible in another.
Ah, okay. So the data will eventually be consistent everywhere, but not instantaneously.
Exactly. Your application needs to be designed to handle that possibility. It's a common pattern in distributed systems.
And there are cost implications, too, I assume. Replicating data isn't free.
Correct. You pay for the data transfer between regions and for storing the replicated data in each region. And you need DynamoDB streams enabled, which also has a cost. But for global apps, the benefits often outweigh the costs.
Okay, so we have scalable partitions, globally replicated tables. But what about actually querying this data efficiently? Especially if we don't want to use the main partition key.
Yeah, you definitely don't want to scan your whole massive table just to find a few items. That's where indexes come into play.
Indexes.
Right.
They let you query on other attributes.
Precisely. They're essentially alternative views of your data structured to make querying different attributes fast. There are two main types, LSIs and GSIs.
LSIs, local secondary indexes. Let's start there.
Okay. LSIs use the same partition key as your main table, but they let you define a different sort key.
So same partition key, different sort key, like find all orders for userid 123, but sort them by order date instead of orderid.
Exactly like that. The key things about LSIs are you have to create them when you create the table, you can't add them later, and crucially, they share the throughput capacity with the base table.
Ah, shared capacity.
Yeah.
So LSI reads writes count against the main table's RCU WCU limits.
Got it.
What about the other type, GSIs?
GSI's global secondary indexes. These are more flexible, I'd say. They let you choose a different partition key and a different sort key from your base table.
Totally different keys, so you could query across all users.
Yep. For instance, find all orders with the status shipped, regardless of which user placed the order. That's a classic GSI use case. And unlike LSIs, you can create or delete GSIs anytime after the table exists. Plus, they have their own provision throughput, separate from the base table.
So much more flexible for those broader queries, but they have their own capacity to manage and pay for.
That's the trade-off. GSIs give you powerful query flexibility across the entire dataset.
So the big picture is, indexes are essential for efficient querying beyond the primary key, preventing costly table scans.
Absolutely. But there's a caution here. While indexes are powerful, especially GSIs, don't go overboard. Each index consumes extra storage and requires its own capacity or shares it for LSIs. Over-indexing is a common mistake. It drives up costs and complexity.
Use them wisely then. Match the index to the specific query patterns you actually need.
Exactly. Be judicious.
Okay, I think we've covered the big three. Partitions for that fundamental horizontal scaling.
Right. The building blocks.
Global tables for taking that scale worldwide, providing low latency and high availability across regions.
Yeah, for your global user base.
And finally, indexes, LSIs, and GSIs, giving you the flexibility to query your data efficiently in different ways.
Unlocking access patterns beyond just the primary key.
It really feels like understanding these three pillars is key to designing well-architected DynamoDB applications.
It absolutely is. Getting these right lets you build systems that are not only scalable and performant, but also cost-effective for your specific needs.
So, thinking about your own applications, how might focusing on partition key design, considering global needs up front, and being strategic about indexing change how you approach building systems for scale and resilience? Definitely something to chew on.